So for number one, we're going to graph the piecewise function f of x equals x plus 5 if our x coordinates are less than -2, and -4 if our x coordinates are greater than or equal to -2. Let's think about how we could put this graph together. Let's start by thinking about what x values work with what. What's a number that's less than -2? What's an x coordinate that I could plug in that's less than -2? Yeah. -3. So let's plot the graph for an x coordinate of -3. Where's the function at for an x coordinate of -3? Plug it into that expression. What's -3 plus 5? 2. So for an x coordinate of -3, if I go left 3 on the x-axis, I can plot the graph at 2. Might need a few more points to get an idea of what's going on here. What's another number besides -3 that will be less than -2? Yeah. -4. -4 would be fine. For any x coordinate that's less than -2, just like -4, we can plug it into this to plot the point. -4 plus 5 would be 1. So left 1, 2, 3, 4. Oh, no. This graph would exist for any x value up to but not including -2. So what happens at -2 when I plug it into x plus 5? What is -2 plus 5? 3. If I go left 2, we'll go up 3 to plot the graph. Would it be an open circle that's excluded or a closed circle that I want to include? Open. Why open? Look at the inequality. Why do we say open here, Trevor?
Because it doesn't have an equal to.
Right. Doesn't have the equal to like the next one down below does, right? X less than -2 is up to -2, but not including -2. So I want to graph as an open point extending down and to the left for our graph. Any x value up to -2, but not -2 itself, can be found on this blue line. Okay. Now let's get the right half. For every x value that's greater than or equal to -2, on the right half of our graph, or on a number line, the function has a value of -4. What's the number for x that would be greater than or equal to -2? A number that's greater than or equal to -2. Yeah.
-2.
-2 would be fine. For an x value of -2, our graph has a value of -4. So plot -2 down 4. Paige, why did I draw this as a filled-in circle and not the closed circle up on top? Right. It's greater than or equal to, not just strictly less than like we had up above. I want to include this coordinate in the graph of the function. What's another number besides -2 that's greater than or equal to -2? Let's get some more points. Yeah.
-1.
-1. For an x coordinate of -1, our function still has the value of -4. So I can go left 1 for our x coordinate, down 4 for the y coordinate. Wouldn't every single x value that's more than -2 always have to be equal to -4 for the graph? It's kind of how this works. For any x coordinate that's greater than or equal to -2, our graph always has a value of -4. At 0, -4. At 1, -4. Get this nice horizontal line. Let's check another one here. How about the one down below? Just cut. All right, Dane, help me out. we're going to graph 2x plus 1 for every x coordinate that's less than 1. What's the number that's less than 1? 0. So if I want to find where the graph's at for an x coordinate of 0, we can plug 0 into 2 times x plus 1. 2 times 0 plus 1 would be what? 2 times 0 plus 1, Dane, would be what? 1. X coordinate of 0, our graph is at 1. Let's get a few more points. Instead of a number besides 0, that would be less than 1. Besides 0, still needs to be less than 1. I think somebody just said it. Negative 1 would be fine. Let's plug in negative 1. Since negative 1 is an x coordinate that's less than 1, we can find where the graph's at by plugging it into this expression. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. So for an x coordinate of negative 1, the graph is at negative 1. For every x coordinate up to but not including 1, we can find that point by plotting 2x plus 1. Let's actually see what happens at 1. What's 2 times 1 plus 2? 1 times 2 plus 2. 3. If I go an x coordinate of 1, the graph is at 3. Would it be an open circle or a closed circle? Open, because just like the last one, we're not including that x coordinate in this part of the graph. It's up to, but not including, every x coordinate that's less than 1. I think for most of these graphs here, on your practice and on Khan, I think they're just pretty much lines. So get a few points plotted and you kind of see what it's going to be. Okay, we need to think of some numbers that are greater than or equal to 1. Riley, what do you say? What's a number, Riley, that's greater than or equal to 1? 3. All right, let's see what happens at 3. If I plug 3 into negative 2x plus 3, what do I get out, Riley? What's negative 2 times 3?
3, or negative 6.
Negative 6 plus 3 more makes negative 3. So if I go right 3, we can plot the graph at negative 3. Luca, how about another number that's greater than or equal to 1? 2. Since 2 is greater than or equal to 1, let's plug 2 in for x to figure out where the graph's at. Negative 2 times 2 is negative 4. What's negative 4 plus 3, Luca? 1. Would it be negative 1, though? There you go. So if I have an x coordinate of 2, the graph is at negative. Let's make sure we get 1 plotted too, because I only have this open circle for an x coordinate of 1 so far. Since 1 is included in this inequality, greater than or equal to 1, I can plug 1 into this graph to figure out what fills in that open circle. Negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. For an x coordinate of 1, my graph is at 1. Some of those points lined up right, but you get the idea. Once again, why a closed circle here and an open circle above? We put an open circle here, why a closed circle down below? Say it? Yeah. This is not equal to, this is. I want to include this point with a filled in circle. I want to exclude this point by leaving it open. All right, you got 1 or 2 on the back here.